this is a companion form of one kind. And this is the first column acts as selected randomly. And then this is the second, third, and fourth column. So we can construct E as a T matrix should be full rank matrix. So let's conclude the similarity transforms. And now we can consider how can we decompose two matrices. For instance, in theory we know that the matrix A of any kind can be decomposed into the product of two matrices. LU decomposition, which means that we have lower triangular matrix and upper triangular matrix. We can decompose the original matrix A into the product of two matrices, two triangular matrices. One is lower triangular, the other one is upper triangular matrix. So we can decompose a matrix into the product of two matrices. And this is called triangular decomposition. And for symmetrical matrices, we can have Chomsky decomposition. And I'll explain it to you later. And then I will give you some idea about positive definites and regular matrices and how to test them. So let's consider first, how can we decompose an original matrix into the product of two triangular matrices? The mathematical form is something like this. And there are certain algorithms for finding L and U matrices. And the algorithm is like this. First, we can have the first row of U, and then we can calculate recursively all the elements in the two triangular matrices. So I'm not going to explain too much about it. Just refresh you. There is in fact an algorithm to find the values in the component in the matrices. And in Matlab, we can code the LU function to find L and U matrices directly. And also, in Matlab, we consider the pivot problem. So we can sometimes construct a permutation matrix P, and then L times U. Let's consider the first example. How can we decompose the original matrix into two triangular matrices? Suppose this is matrix A, and we can code the LU function, and we can get two matrices L1 and U1. And as a result, we can see that U1 is itself a upper triangular matrix, but L1 is not, because some numerical computation is some techniques in numerical computation is required. They use the pivot technique. So if you consider insert the fourth row into before the second row, we will say is a lower triangular matrix. So when using Matlab function LU, you will not normally. Sometimes you will not get a real lower triangular matrix. There are some mathematical numerical computation are required in it. So this is the Matlab function LU. It is flexible for numerical matrix A. And let me recall the theoretical computation formula. Based on this formula, I write myself a Matlab function like this. And this function, I can put it in the S7 directory. So it means there are two LU functions. One of them is in Matlab directory. The other one is in S7 directory. We have two functions and their Matlab path. So what's the difference between them? So this is the function I wrote myself. And in this function, I didn't consider the pivot problem. So what's the difference between the two? If you have a matrix A, and if you call the LU function, it will check what is the class or what is the data type of it. If A is a numerical matrix, then it will find this function automatically. It will use numerical method to perform LU decomposition. However, if A is a symbolic matrix, it will search for S7 directory and find this function. So these two functions are not do not conflict with each other. So it will check first what is the data type of A, and then find the proper function to process it. So for the same example, what we need to do is to convert A matrix into a symbolic matrix first, and they will lead to a function call to this function, to S7 directory. And what we will finally get are the two matrices, the lower rectangular matrix and the upper rectangular matrix. Right? So this is the LU decomposition. As a special case, if matrix A is a symmetrical matrix, then we can decompose the original matrix into two matrices, L and the transpose of L, where the form of L is something like this. It's a lower triangular matrix. So this kind of decomposition is referred to as Chomsky decomposition. So it applies only to symmetrical matrices. And this is the algorithm. This is the algorithm used. And in Matlab, you can call the CHOL function to perform Chomsky decomposition of the original matrix. And this function is for numerical matrix A. And also there are theoretical algorithms to find all the terms in the lower triangular matrix. And based on this algorithm, I wrote a function myself, CHOL, which should have the same name as the Matlab function, but also plays in the S7 directory. And this function can be used to perform symbolic computation to find the lower triangular decomposition L. And it should be noted that the CHOL function can only be used for symmetrical matrix. If a matrix is not symmetrical, then the result might be wrong. So it is only applicable to symmetrical matrices.